Have you ever received data from an API, tried to access one deeply nested value, and suddenly got this error? Cannot read properties of undefined. This is one of the most common daily frustrations for front-end and back-end developers. Your API response looks correct in one case, but another user has missing profile data. No address, no uploaded image, no items, or a partially completed form. Then one unsafe dot access can break the current code path and leave your UI in an error state. In this video, we'll learn the right way to safely handle nested API data in modern JavaScript using optional chaining, nullish coalescing, safe array handling, and a few practical patterns you can use immediately. Small but important clarification before we start. APIs usually send JSON, which is text in a structured format. Once you parse that response, for example with response.json, JavaScript gives you a normal JavaScript object. So throughout this video, I'll say nested JSON data because that is how developers commonly describe it. But the code we access is usually a parsed JavaScript object. Here is a realistic e-commerce order response. It has several nested levels. To access the city, we might write const city equals order.customer.shipping.address.city, console.log city, Colombo. This is perfectly valid, as long as every part of the path exists. But API data is not always complete. A user might not have set a shipping address yet. The backend may intentionally return null. A property may be omitted due to permissions, or a backend change may temporarily alter the response structure. Now, JavaScript successfully reads order, then customer, then shipping. But shipping is undefined. When JavaScript tries to read .address from undefined, it throws a type error. Technically, this does not always mean the entire application permanently dies. But if the error is not handled, it interrupts the current code path. In a UI, that can mean a component fails to render, data disappears, or the user sees an error screen.
Before optional chaining existed, developers often used logical AND checks. The idea is simple. JavaScript evaluates from left to right. If one part is falsy, it stops instead of trying to continue deeper. So this prevents the type error. But look at the cost. The code is repetitive, hard to scan, easy to mistype, and harder to maintain when your object becomes larger. This approach still exists in older code bases, and it is useful to understand. But for modern JavaScript, optional chaining is usually the cleaner choice. Optional chaining uses ? dot. It means access the next property only if the value before it is not null and not undefined. Let's read this slowly. Order ? dot. Customer ? dot. Shipping ? dot. Address ? dot. City. First, check whether order exists. Then check whether customer exists. Then check shipping. Then address. If any value in this chain is null or undefined, JavaScript stops safely and returns undefined instead of throwing an error. This is safe navigation through a nested object. Optional chaining does not create missing data. It does not fix your API. It simply prevents your application from crashing while trying to access data that is absent. Optional chaining specifically protects against null and undefined. It does not treat every falsy value as missing. For example, an empty string is still a valid value, 0 is still a valid value, and false is still a valid value. That distinction becomes very important when we add fallbacks.
Returning undefined safely is good, but we usually do not want to show undefined in the UI. We want a meaningful fallback. This is where the nullish coalescing operator, comes in. It means use the value on the right only when the value on the left is null or undefined. Many developers use logical or sign, for fallbacks, but or uses a broader rule. It falls back whenever the left side is falsy. Falsy values include 0, an empty string, false, null, undefined, and nan. that can create bugs with API data. In this example, 0 is a valid stock value. It should mean there are 0 items available. But stock level or out of stock treats 0 as falsy and replaces it. Nullish coalescing is safer when 0, false, and empty strings are valid values that you want to preserve.
Use double ? when the fallback should happen only for missing values, specifically null or undefined. Use double pipe only when you intentionally want all falsy values to trigger the fallback. In a React component, API data may be unavailable during the first render because the request is still loading, or the data may be partially complete. Optional chaining helps us render a stable UI while that data is loading or while optional fields are missing. But be careful. Optional chaining is not a replacement for proper loading, error, and empty states. A reliable UI should still handle loading and request errors clearly. Optional chaining protects property access. It does not tell the user whether the request failed, whether the data is still loading, or whether the backend returned invalid data. Nested arrays are another common source of bugs. Suppose an order has an items array. We may want the first item's name. Const first item name equals order.items0.name. This fails if items is missing, if it is null, or if the array is empty. The safer version is const first item name equals order.items ? .items ? .0 ? .name ? no items. Notice the optional chain before the array index. Items ? .0 means only try to read index 0 if items is not null or undefined.
Now let's map the item names. This unsafe version fails if items is missing. The safe version uses optional chaining before .map. Const item names equals order ? .items ? .map item.name ? array. If items exists, it returns the mapped names. If items is missing, it returns an empty array instead. This is especially useful because an empty array is easy to render safely in UI code. Here is a practical total calculation. We safely handle missing items, missing prices, and missing quantities. However, whether replacing missing price or quantity with 0 is correct depends on your business rules. In some systems, missing price data should be shown as an error instead of silently becoming 0. Optional chaining also works with functions. Sometimes you receive an optional callback. If it exists, call it. If it does not, do nothing. OnSuccess ? This is cleaner than checking if onSuccess first. Be sure that the value is either a function or missing. If it is a non-function value, optional chaining will still throw when JavaScript tries to call it.
Optional chaining is powerful, but do not use it to silently ignore data that must exist. For example, an order ID may be essential. If it's missing, your application may need to stop, log an error, show a retry action, or report an API contract issue. In that situation, optional chaining is useful for checking safely, but you should handle the invalid state deliberately. If not, order.orderID, throw new error, invalid order data, order ID is required. A good rule is this: use optional chaining for fields that are genuinely optional. For required fields, validate them and handle bad data explicitly. You can also use safe defaults with destructuring style workflows. One readable option is to pull each layer out safely. Const customer equals order.customer or empty object. Const shipping equals customer.shipping or empty object. Const address equals shipping.address or empty object. Const city equals address.city or address not provided. This can be useful when you need several properties from the same nested branch, but do not overdo it. If you only need one value, this is often simpler. Const city equals order.customer.shipping.address.city or address not provided.
Let's summarize the practical rules. Use optional chaining when a nested field is optional. Use nullish coalescing when you need a default value, but still want to preserve 0, false, and empty strings. Use safe array access when working with API lists. And remember, safe access does not replace validation. Your application should distinguish between optional data, loading data, failed requests, and invalid required data. Here is the pattern to remember. Use optional chaining to navigate safely. Use nullish coalescing to provide a meaningful default. Const value equals data.deep.nested.path $default value. This one pattern prevents many common runtime errors and makes your API handling code much cleaner. Here is your challenge. Given this profile object, safely display the theme. If the theme is missing, show system. Try it using optional chaining and nullish coalescing. Comment your answer below.